Lesson 14.11, definite integrals with substitution type 1. So this substitution is called that U substitution we've done before, but now that we're integrating, it's going to cause us to change everything in terms of U. That's the key concept to this lesson. So we've got f is a function. It's 1/4 x plus 2 equals negative 20. Write an equation that can be inferred involving the interval of the function f of u. So what you want to do is make the inner function be your u. So I'm going to make a substitution that u is going to equal 1/4 x plus 2. That's step number 1. Step number 2 is take the derivative of u with respect to x. So I'm going to put du. Before I think we put it over dx, what I actually think is easier is taking the derivative of this. Now, not thinking antiderivative, just normal derivative, what we spent like the first 3/4 of the year on. This would be just 1/4. But since I'm taking it with respect to u and I have a different variable, I need a dx. This is like when we did implicit differentiation and I had a derivative of y with respect to x and I wrote y prime. That's the same thing. The other thing you could do is have this over this and then have 1/4 and then make it a proportion, cross multiply, but I think this is faster. But now what I want to solve for is dx, because I'm going to want to make a substitution, get this out of dx and have this in terms of u. So I'm actually going to just, I think multiply by 4 would be the easiest, right? Instead of dividing by 1/4, let's multiply by 4. So I'm going to put that dx really equals 4 times du. Now I don't need this middle step. I just need this and I need this. Okay, so I'm going to write my integral sign. I'm not going to put -4 and 0 yet. I'll show you why. Now I'm going to have f, and I replaced this with u, and then dx needs to come out. And instead I'm going to put in 4 du, and that's getting multiplied. And that's equaling -20. Okay, so now I need to change my bounds because these are in terms of x values and I am no longer in terms of x values, I'm in terms of u values. And so think of it as a proportion. You're trying to proportionally change it, but what we know is that u is 1/4 of x plus 2. So you're going to have to plug those bounds in to this function right here for x. So u is going to equal 1/4 of 0 plus 2, which would be 2 for my upper bounds. And then u would be 1/4 of -4 plus 2, which would be -1 plus 2 is 1. So now we're saying we're going from 1 to 2. I know that doesn't look proportional. That's not really what I mean, but it's in a different format, kind of. It's in a different term. So don't worry about it as long as you think you plugged in correctly. Now, I need to know properties. This times 4 here can actually be taken out. And so I'm going to put 4 times the antiderivative from 1 to 2 of f of u du equals -20. Well, they don't want the 4 here. They want to know what is this equal to. So I'm going to have to treat it like an algebra problem where if I have 4x equals 20, I'm going to divide by 4. That's what I'm doing. So divide by 4, that gets -5. So now I can say from 1 to 2, f of u du equals -5. So you'll have to put in your new a and b values. That'll actually change it on Delta Math. They'll automatically put those numbers there for you. And we're now saying that this should equal -5. And that's all you do on that type. The more you practice, the easier it'll get. Number 2, f is a function. We're going from -1 to 15. Look, it's f of u du equals 4. What must be the value of 0 to 4? F of 4x minus 1 dx. So we want to convert this in terms of u. That's where I always start. So my substitution is going to be the inner part here, which is the 4x minus 1. I take the derivative of that with respect to u, so that would just be a 4, but then I'll have to have a dx, or an x prime. Then I want to get it solved for dx, so I'll divide by 4. So now I have that dx equals du over 4. So I'm using this, and I'm using this. So I'm going to write, and I'm going to leave those blank for right now. I'm going to write f of u. I'm replacing dx with du over 4. Or you could put 1/4 times du if you'd rather. Now I'm going to change my bounds. So since these were x values, I need to know, oh, sorry, wrong spot. Since these are x values, I need to figure out what they would be. They should match this. So right here it says u is going to equal 4 times 4 minus 1. That's 16 minus 1, that's 15. And see, it matches. And then if I plug in 0, 4 times 0 is 0. 0 minus 1 is -1. Okay, and then they've got that this equals 4. So I'm going to actually factor this out since this is a 1/4. I'm going to write that this is now 1/4 times the integral -1 to 15 fu du. And then that equals 4. So I don't want it to stay like this. I want to multiply by 4 on each side. So now that makes that equal 16. So what is the integral of this? It would be 16. Number 3, write an integral that is equivalent 1 to 4 x times f of x squared plus 3 dx. So we're going to do another u substitution. U is going to be just the inner part. I won't worry about the x right now, but you'll see that it cancels out of there. We've got x squared plus 3. Taking the derivative of that would become 2x. But then I'm going to have dx. The constant goes away. I want dx solved for, so I'm going to divide by 2x. So dx equals du over 2x. I'm ready to substitute. You could go ahead and change your bounds or wait just a minute. I'll have x still in it times f of u. Dx is now du over 2x. So do you see here that this and this will cross cancel? That's great because we can't have x's in there. Now 4 needs to get plugged in here. So if x is 4, that's going to be 4 squared plus 3, which is 16 plus 3 is 19. If x is 1, that's going to be 1 squared plus 3, which is 4. Okay, and now I'm going to factor out this 1/2. So I'm going to have 1/2 times the integral 4 to 19 f of u times du. F of u with respect to u. So you'll have to put in your new bounds that it's a is 4 to 19 is b. That'll change it here and here for you. Now we want that 1/2 times f of u du. So it's just basically practicing slowly what u substitution looks like in these problems.